Welcome to my fourth math tutoring session for the SAT. This one is going to go over a lot of the Math Module 2 harder multiple choice questions and a lot of constant questions which have been seeming to appear more and more on the SAT recently. The first topic we are going to go over is making linear functions in context. So what I used to do when I always saw these questions is, depending on the context, I would just try to figure out the questions by that. But I figured out a formula that helps you pretty quickly get every single one of these questions. In that formula is the original price of the context minus the new price of the context times n. And that n is going to be the total amount of people that they charge the original price with. And I'll show you guys what that looks like in a second. The original price is the charge for the first n amount of people, and then that new price is going to be the charge after the first n amount of people. So let's say, let's just write this down. Times n. And it's going to give you that original price minus the new price times n is going to give you what you would see as the b in your y equals mx plus b. So let's say this was all equal to 30, then you would have y equals mx plus 30. And then the slope in this equation is going to be the new price. So whatever you use right here is going to match up with this. Alright, let's look at a few questions. For groups of 25 or more people, a museum charges 21 per person for the first 25 people and 14 for each additional person. Which function f gives the total charge in dollars for a tour group with n people where n is greater than or equal to 25? So, if we go back here, we see that the original price is the charge for the first n amount of people. Let's figure out what that is. It says a museum charges 21 per person for the first 25 people. So you have your original and your n. Your original is 21, and your n is 25, because it's for the first n amount of people, so that n is going to be 25. Now we need to figure out what the new price is. A museum charges 21 per person for the first 25 people and 14 for each additional person. So your new price is going to be that $14, because after 25 people, they're going to start charging 14. So now you have your equation, and you know the slope of your new equation is going to be have that new price right in front of the x, so it's going to be 14x plus whatever this is equal to. 21 minus 14 is 7. 7 times 25 is 175. So your equation is going to be y equals 14x plus 175, and that's going to give you a. They use n and they use f of n. I always write y equals mx plus b, and then I just look at where the variables line up. The cost of renting a backhoe for up to 10 days is $270 for the first day and $135 for each additional day. Which of the following gives the cost y in dollars of renting a backhoe for x days where x is a positive integer and x is less than or equal to 10? That last part doesn't matter. The last part on the first question did not matter. So it's $270 for the first day. So your original price is $270. And then for the first day, so n equals 1, because it's just 1 day they charge the original price. Your new price is $135 for each additional day. So, we have our new price. We can go ahead and plug that into the slope of our equation, y equals 135x. And then your constant at the end is going to be whatever this equals. And 270 minus 135 times 1 is just 135. And which answer choice matches up with that? It's going to be D, it looks like. Okay, next question. A window repair specialist charges $220 for the first 2 hours of repair plus an hourly fee for each additional hour. The cost for 5 hours of repair is $400. Which function f gives the total cost in dollars for x amount hours of repair, where x is greater than or equal to 2? Well, we're given our original price and n again, so let's go ahead and put those in. 220 minus, we don't know yet, because it's 220 for the first 2 hours, so that's your original price, and then it's going to be the first 2 hours, so your n is equal to 2. The total cost for 5 hours of repair is $400. That $400 is not your new price. That $400 is the total price for 5 hours of repair. So we need to figure out how to get the new price. And how you want to do that is, if it's $400 total for 5 hours, we know the first 2 hours is 220. So we would do 400 minus 220 and get 180. So now this 180 is going to be evenly split among the last 3 hours, because it says an hourly fee for each additional hour. That's assumed to be constant. So 180 divided by 3 is 60 per hour. So your new price after the 220 for the first 2 hours is 60 per. So you put in 60 here. And also the original price isn't 220. I'm wrong about this. It says 220 for the first 2 hours. 220 divided by 2 is 110, because it's 110 per hour, not 220 per hour. So you have your 60, which is your new price. So y equals 60x plus, and then our constant we find by using this equation. 110 minus 60 is 50. 50 times 2 is 100. 50 times 2. Gonna have to squish this in over here. So your final equation is y equals 60x plus 100, and that is A. Is there any questions about how to do this problem? To move on. Okay, next is creating equations with a variable. So this is just what it sounds like. You're going to be given a bunch of information in the question, and you're going to want to create an equation with that information, and it's going to have a variable in it. It's not going to be all numbers. So the first thing you want to do is figure out what unit the variable is in, because it's going to give you a unit measure, but it's also going to give you an amount. And I'll show you what that means in the first question we do. So what you want to do to find out what unit that variable is look for the equal sign in the answers. It's going to say all of the information stacked up together is equal to this specific thing, and that's where you're going to usually find what your unit is. And then as always, we went over this in the last tutoring session. Is means equals in math SAT no matter what. So let's go over the first one. Each side of a 30-sided polygon has one of three lengths. The number of sides with length 8 centimeters is 5 times the number of sides with length 3 centimeters. There are 6 sides with length 4 centimeters. Which equation must be true for the value of n? So it says which equation must be true for the value of n. So we're looking for what n is, and n is the number of sides. So what we know off this equation, we can automatically disregard the lengths. We can disregard the 3 centimeters, the 4 centimeters, and the 8 centimeters, because we're looking for an equation that calculates the number of sides. And we know the polygon has 30 sides total, so whatever our question is, it's going to be equal to 30, as shown in the answer choices. It says the number of sides with length 8 centimeters is 5 times the number of sides n. So the number of sides with length 8 is 5n times the number of sides n with length 3. So we know the number of sides with length 3 is n because it says the number of sides with length 8 is 5 times that amount. So that's going to give you 5n plus n, and it says there are 6 sides with length 4, so it gives us that there are 6 sides with length 4. So that's going to give you this piece, and then 5n plus n is 6n plus 6 equals 30. So these questions are quite hard to get. I would say you just want to look at these questions over and over and over again. You want to know what you're looking for most of all, because someone would get super easily tripped up seeing the number of sides and then it gives all the length. They might try to use lengths in their equation, but it has nothing to do with lengths at this point. This whole equation is asking about the number of sides. Is there any questions about that problem? Okay. A manufacturing plant makes 10-inch, 9-inch, and 7-inch frying pans. During a certain day, the number of 10-inch frying pans that the manufacturing plant makes is 4 times the number n of 9-inch frying pans it makes, and the number of 7-inch frying pans it makes is 10. During this day, the manufacturing plant makes 100 frying pans total. Which equation represents this solution? So at the end of that problem, it says during this day the manufacturing plant makes 100 frying pans total. So everything total is equal to 100. So we know our right side of the equation is going to have equals 100 in that side. And again, since this is talking about amount of frying pans, we can automatically disregard the 10, the 9, and 7 inches. We're not talking about measures, we're talking about amount. So the number of 10-inch frying pans that the manufacturing plant makes is 4 times the number n. So this is kind of the same setup. So the number of 10-inch frying pans is 4 times n. And then we know n is the number of 9-inch frying pans it makes, because it says that in the same sentence there. It says the number n of 9-inch frying pans, which means the amount of 9-inch frying pans it makes is n. And then it gives us that the number of 7-inch frying pans it makes is 10. So you can automatically add 10 right here, and then combine your variables. 5n plus 10 equals 100. So your answer is going to be C. Whoa. D, sorry. A factory makes 9-inch, 7-inch, and 4-inch concrete screws during a certain day. The number of 9-inch concrete screws that the factory makes is 5 times the number n of 7-inch concrete screws, and the number of 4 concrete screws is 22. During this day, the factory makes 100 concrete screws total. Which equation represents this situation? Well, we see the 100 on the right side of that equation, and it's talking about the amount. So we can disregard the lengths again. Now we just need to figure out what each amount is. The number of 9-inch concrete screws that the factory makes is 5 times the number n of 7-inch concrete screws. So 9-inch concrete screws is 5n, and then that 7-inch concrete screw is n, and the number of 4-inch concrete screws is 22. So these questions are all very similar formed. I've seen 2 of these questions in the hard math module 2 section out of like the 5 SATs I've taken. But a good thing about these questions is if you're prepared for them, and this is like a question 17 on math module 2, it takes 30 seconds. And you want to always make sure to save that time if you're going for a super high score here. So 6n plus 22 equals 100. So your answer is going to be D. Okay, so this is kind of 2 different things, but they're similar enough and they go on the same kind of topic wavelength that I put it into one. Finding solutions with letter variables and with constants. So for finding solutions with letter variables, if there's only one letter, just plug the equation into Desmos with that squirrely sign right there. And if it has an x, then you have to distribute all the numbers out and figure out what makes those x coefficients equal to each other. Because it's either going to say it has no solutions or infinite solutions. So you need the x coefficients to be equal so they have the same slope. So let's go ahead and look at the first type of question. So it gives us the equation 5t plus 3 minus 7t plus 3 equals 38. What value of t is the solution to the given equation? So I'm going to go in and type this into Desmos. 5t plus 3 minus 7t plus 3 t plus 3 equals 38. And instead of that equals sign, I'm going to put that little squiggly sign here, and then equals 38. So it's giving me t equals negative 22. So the value of t that would make the solution to the equation is negative 22. That is your answer. Done. I've seen probably 3 of these types of questions overall for hard math module 2. What value of t is the solution to the equation 0.8t minus 0.46 equals 8 times t minus 0.001 plus 1.9? Well, you do the same thing here. You're going to plug it into Desmos. 0.8t minus 0.46 equals 8 times t minus, what was that, 0.001 plus 1.9, and I put an equal sign instead of that squiggly sign. Once you put the squiggly sign, it puts it into regression, and then t will equal negative 0.326667. In the given equation, k is a constant. The equation has no solution. What is the value of k? So the equation is 3 times kx plus 13 equals 48 over 17x plus 36. So the thing you want to notice here is this equation has x's in it. So 3 times kx plus 13 equals 48 over 17 x plus 36. So you want to distribute this out. It says the equation has no solution, so that's how you know that you want your x coefficients to be equal to each other, because that's the only way you're going to get a problem with no solution. So distribute this 3kx plus 39 equals 48 over 17x plus 36. So now you have this equation right here. And now that you have it fully distributed, you want that 3k and that 48 over 17x, or 48 over 17 to be equal, because you want to, as I said back here, set the x coefficients equal to each other. So 3k, and I'm going to use that squiggly line again, equals 48 over 17. So this is the answer to your equation. It would be k equals 0.9411. In the given equation, k and n are constants and n is greater than 1. The equation has no solution. What is the value of k? So we see that x, so we're automatically going to want to distribute everything here. Minus 36 over 19. So here we go, distributing 2kx minus 2n equals negative 28 over 15x minus 36 over 19. And again, this question says the equation has no solution. So it's asking for the value of k. It really doesn't matter what n is at this point. So you're just going to want to plug in for k. So you want 2k, because that's the coefficient of this x, to be equal to negative 28 over 15. So go ahead and plug this into Desmos with that little squiggly sign. Negative 28 over 15. So k would be negative 0.933 repeated. Finding points is R. Now this is one I've seen for the hard math module 2. This has been question 20 to 22 on I think 3, if not 4 of my SATs. I think this has appeared on all of my SATs I've seen. Finding points is R. Put x on one side and y on the other. That's the first thing you want to do when you come across these equations. So let's say you had like x minus y equals y plus 2. You want to add that y over. X, put that on this side. X equals 2y plus 2. You just want to make sure you have both variables separated. And do whatever variable's easier, but make sure your answer shows the variable like that. Look to answer choices to figure out where the constant goes, left or right side. I'll show you what that means when we go into the problem. And then once in XY form, just plug in R. Let's look at a practice problem. 8x plus 7y equals 9. 24x plus 21y equals 27. For each real number r, which of the following points lies on the graph of each equation in the xy plane for the given system? So these questions always do the same thing. They have two equations, and both equations are equal to each other. As you can see, if you take out a GCF of 3 in the second equation, 24 divided by 3 is 8, 21 divided by 3 is 7, and 27 divided by 3 is 9. You just get the previous equation, so these are the same equations. So I'm going to work with the smaller equation because that's the easier equation to work with. And then what you want to notice is all of your answer choices look like coordinate points. They have that x side and that y side. If I write out this answer choice r, negative 8r over 7 plus 9 over 7, that just looks like a coordinate point, this side being x, this side being y. That was translated. So now I'm going to solve for one of the variables because you always want to get one of the variables by itself. So I'm going to subtract this 7y over 8x equals negative 7y plus 9. And then I'm just going to divide this 8 over x equals 2 equals sign there. X equals negative 7 over 8y plus 9 over 8. So we are going to want to see if this looks similar to any of our answer choices. If we converted this to r, this doesn't look like any of our answer choices. But since we got x by itself, we can see that a can't be correct, because if we converted this to r, then it would be r equals negative 7 over 8 r plus 9 over 8, which is different from a. So a cannot be the correct answer. I don't know why I erased all that. We had x equals negative 7 over 8 y plus 9 over 8. Let's keep working with what we have here. Now we want to get it into the other form. So let's try getting y by itself. So y equals 7y equals, I'm just going to subtract that 8x over instantly. Negative 8x plus 9. Divide this 7. Y equals negative 8 over 7x plus 9 over 7. And then if you want to write this in xy form, negative 8 over 7x plus 9 over 7y. And that looks very similar to our answer B. Once you convert it into r's, it's going to be negative 8 over 7r plus 9 over 7, comma r. So that is your correct answer. Systems of two linear equations with constants. So for these type of questions, you want to combine the y's and the x's. 1 second, sorry. So for systems of two linear equations, when you have these constants, you want to simplify the equations as much as possible, because that's going to show you what you need to do with the constants. Make the given coefficient to x or y equal. I'll show you what that means when we do the first problem. One will have a variable and the other will have a constant. Make the constant equal in both equations. and then make sure the given constant has the same sign in both equations. So let's go to a practice problem. In the given system of equations, p is a constant. If the system has no solution, what is the value of p? So we have 3/2 y minus 1/4 x equals 2/3 minus 3/2 y. So again, you want to simplify this as much as possible. I'm going to add this y, 3/2 y over, and that'll give me 6/2 y, or 3y. 3y minus 1/4 x equals 2/3. That's about as much as you can simplify that for now. I'm going to leave this equation here and then work on the second equation. 1/2 x plus 3/2 equals py plus 9/2. So, I want to get these equations to look similar. So I'm going to subtract over the 1/2 x and then subtract over the 9/2. Minus 1/2 x and then minus 9/2, and that'll give me, I'm going to put the constant on this side, so equals 3/2. Py, that's not going to be 3/2, 3 minus 9/2, that's going to be negative 6/2 or 3. Py minus 1/2 x equals negative 3. So now I have my both of my equations simplified about as much as I can get them simplified. So now it's given to us that the equation has no solution, and we need to find this value p here. Well, for the equation to have no solution, both the x and the y must have equal coefficients to each other, and the only value that can be different is the b. So I'm going to go ahead and set both of these x's equal to -1 to make the question a bit easier. To do this for this first problem, I'm going to have to multiply everything by 2. So 2py equals, or 2py minus x equals -3. And then the second equation, I'm just going to multiply it by 4. So 12y minus x equals 4 times 2, 8/3. So now that we have them in the same order, we want both the coefficients of x and y to be equal. So that 2p is going to be equal to 12. We could throw this in Desmos, or we could just find p as doing work. You just divide the 2 over, p equals 6. These problems, they're definitely not the easiest problems to do when you see on the SAT. And a lot of people, what you can do is they plug both of the equations into Desmos and then use p as a slider. But it's such a common mistake to think you have no solutions and not actually have no solutions. You have to really zoom out, and even sometimes then you don't get the right equation. So I do these by hand, but what it would look like if you did it in Desmos is 3/2y minus 1/4x equals 2/3 minus 3/2 y. And your second problem is 1/2 x plus 3/2. 1/2 x plus 3/2 equals py plus 9/2 equals py plus 9 over 2. So we would go ahead and add a slider for p, and then we'd wait till we find the spot where they are not equal to each other. So it looks like it's going to be in between 8 and 4, so I'm just going to set the slider between 4 and 8. If I do this, now this is where it's hard to see because there's obviously a thing here. You have to click on the graphs each time you think you have it, and then you'd have to shuffle right over p equals 6 to finally get that there's no solutions. So if you have an integer constant, if it says that this is an integer constant, you can do this, and then you could do step 1. So it's only going to give you integers, and then this will work for you for these types of questions. But if it's just a constant, it could be like 5.3627, not divided by point, the answer. And you would never be able to get it with the slider. So that's why I do these by hand. If it says integer constant, though, you can't do it with Desmos. In the given system of equations, h is a constant. If the system has no solution, what is the value of h? So I'm going to make both of these easier for me to see. The second equation is already simplified as much as it can be. So I'm going to try to put the first equation in y equals constant plus x form. So I'm going to add over that 9y. It's going to give me 18y plus 5. And if you guys are confused on where I got this piece of equation from, just ask and I will explain. So I want to get that constant over on the x side, so I'd subtract 5 over. So 18y equals negative 5 plus 4x. So this is the first equation in the same form as the second equation. In this, these two equations are nice because it already has equal x coefficients, so you don't have to set the coefficients equal to each other. You just need to know that the y coefficients need to be equal now. So h is equal to 18 because the other y coefficient is 18. So your answer choice here would be D. And when they give you answer choices, you can just plug in. You can put both equations into Desmos, and you can plug each answer choice in until you find the one without a solution. In the given system of equations, g and k are constants. The system has infinitely many solutions. What is the value of g over k? So it gives us 2 over 5x plus 7 over 5y equals 2 over 7. And then gx plus ky equals 5 over 2. So what you want to do here is, it says the system has infinitely many solutions. So you want your coefficients of your y's, your coefficients of your x's, and your y-intercepts to be the same, which is that b, right? These are all just y equals mx plus b in different forms. So you need these numbers to be the same as well before you can find g and k. So we're going to go ahead and make those the same. And I would set them both equal to 1. And the way you do that is you just want to multiply both sides of the equation by the reciprocal. The reciprocal to 5 over 2 is 2 over 5. So multiply this side of the equation by 2 over 5. 2 over 5gx plus 2 over 5kx, or ky, equals 1. So now you have this coefficient to be 1. Now you want to set your second coefficient equal to 1. So the reciprocal of 2 over 7 is 7 over 2. So you would multiply all of this by 7 over 2. 2 over 5 times 7 over 2 is 14 over 10. Because 2 times 7 is 14, 5 times 2 is 10. So 14 over 10x, 7 times 7 is 49. 5 times 2 is 10, so 49 over 10y equals 1. So now I have my two equations. They have an equal coefficient. So now we know both g and k have to be equal to the x and y coefficients respectively for the top equation. This is a 14. So 2 over 5g equals 14 over 10x. We're going to put that into Desmos. 2 over 5g, squiggly line, 14 over 10. Because you want the coefficients to be the same. So g is going to be 3.5. And then k, 2 over 5k is going to be equal to 49 over 10y. 1 second here. This has done this every single time. There we go. 2 over 5k is equal to 49 over 10. It's equal to negative 49 over 10 because there's a minus sign out front. So 2 over 5k, squiggly line, negative 49 over 10. So k equals negative 12.25. So what is g over k? Well, g is 3.5, k is negative 12.25. So I think it honestly works if you just do g over k like this. And yes, it does. It is going to give you your final answer of negative 0.2857. Oh, these are both plus. I don't know where I got the minus sign from. This is a plus, and that 12.25 is going to be positive. So this is going to be positive 2.8, or 0.2857. Is there any questions on how I got to that answer? And if you want to check these answers, just plug the equation back into Desmos. 2 over 5x plus 7 over y equals 2 over 7. 2 over 5x plus, what was it, 7 over 5y equals 2 over 7. 7 over 5y equals 2 over 7. So this is that equation. And now you have your g and your k. G equals 3.5, so 3.5x plus 12.25 y. Oh. 2 over 7. Different one. 3.5. Oh, it's 3.5 times 2 over 5 because the constant's still there. X plus 2 over 5 times 12.25 y equals 1. So when you're zoomed out like this, you can press these buttons and you can see that the equation is perfectly lined up together. So that's going to show you your infinitely many solutions. So if you have time, I definitely would recommend checking these. Checking this is very easy. All you have to do is plug into Desmos. And remember, on test day, you're not going to have to switch back between your problem and Desmos, because you can have Desmos pulled up to the side in like a little corner or something. So it's going to be way quicker to type these types of problems in. So next we're going to go over hard equivalent expressions problems. Now, I've had the most trouble with equivalent expression over anything. These are, in my opinion, the toughest questions on the SAT. Maybe some of the ones further down, some of them are easy. You just gotta know what you have to do, and then it makes these a lot easier. So this is going to use regression parameters, so you're going to use that squiggly line to set both equations equal to each other. And then when you, here I'll show you guys in Desmos. When you go to do something like this, like let's say you had like kx plus 7 equals, or equals like 4x. It's going to pop up with that caution sign right here. You need to set your x's to x sub 1s to actually get what you want. So it still counts x as a variable when you're using regression if you don't set that sub 1. Now you can use another variable in place of x, but I always like doing x1 because if you go into Desmos and you click x and then you just click 1 right after, it doesn't go after 1. It just automatically does that little sub thing. Any number you put in x is going to do subscript, and it's the same thing with y. It's going to automatically transfer that number into subscript. You don't have to do anything special to put it in subscript. Like I said, do this by typing in that 1 after your x. If it's given that your variable is said to be greater than n, set the variable equal to n plus 1, n plus 2, n plus 3, n plus 4, n plus 5. What I mean by this is if a question, let's just go look at one of our questions. That second question says x is greater than 1. So I would put x equals brackets 2, 3, 4, 5, 6, 7. It would be x sub 1 because that's what I'm going to be using. Whatever your variable usually is in the equation, you want to set it to multiple numbers because Desmos will automatically solve it in like the easiest way. It'll give you just spout a random number. I think it's the number that's closest to 0. You don't want that, so you're going to set what usually is your variable to multiple numbers. And then let's go ahead and see what all this looks like combined together. The given expression can be rewritten as a times 4x squared plus 7x plus 3, where a is a constant. What is the value of a? So if this expression can be rewritten as this expression, then they're equal to each other. So we're going to use that squiggly line and make sure to set them equal to each other. So 0.3x, remember your sub 1 squared, 0.36x sub 1 squared, plus 0.63x plus 1.73, 0.63x plus 1.73, I believe that was what that was, 1.17. Always make sure to double check all of your typing into Desmos. Squiggly line. In that 0.63 is supposed to have an x right here, x1. A times 4x squared. A times 4x1 squared plus 7x plus 13. 7x1 plus 13. And it's going to give you a equals 0.09. So that is going to be your answer. I would personally do x1 equals just in case it gives you something close, make sure it equals 0.9 for all the different variables you can list out. Make sure for multiple elements it is equal to 0.09. So a equals 0.09 is going to be your answer to this question. Now we'll move on to here the expression 6 times 3 to the 5th times x to the 45th to the 5th root times 2 to the 8th x all to the 3rd root is equivalent to ax to the b, where a and b are positive constants and x is greater than 1. What is the value of a plus b? So we're going to type this all into Desmos. 6 times 3 to the 5th times x to the, what was it, 45? X to the 45th. And that's all going to be raised to the 1/5. Times 2 to the 8 times x, 2 to the 8 x. Oh, set all these equal to x sub 1. 2 to the 8x, all to the 1/3. And again, on test day, you're not going to have to go back and forth like this. I believe that all is right. And then this is equal to a xb, equivalent a x1 to the b, I believe. And it says x is greater than 1. So what we want to do is set x1, because that's what we're using in place of x, equal to brackets. It's not 1 because it's greater than 1. And then you want to make sure you list everything out. And it says, what is the value of a plus b? I'm going to make sure I've everything typed in right. 6 times 3 to the 5th times x to the 45th to the 5th. That might be an 8. 1 second. I cannot tell if that is an 8 or not. 2 to the 8x is equivalent to axb. Yeah, that's an 8. Okay. So, I thought that was a 3 at first. I messed up typing that in. It's going to be more clear on the problems on test day. So it's equivalent to axb, where a and b are positive constants. What is the value of a plus b? So it gives us a and b here, a plus b. I thought it was going to do that. 36 plus 9.125. And that's going to give me 45.125, and that is going to be your answer to this one. For what value of x is the given expression equivalent to 70n to the 30x, where n is greater than 1? So x is actually used as a constant in this one, so we're still going to set it to x1, but our n, as you can see, is the actual variable. So this is 70n to the 5th, 70n to the 1/5, not to the 5th, to the 1/5, yeah. And then times 70n to the 1/6 squared. So we're going to have to put that second part in parentheses. 70n to the 1/6, I believe. Yep, 1/6 squared. And then that said that was equivalent to 70n to the 30x. 30x1. And then it gives you these two numbers. N is greater than 1. So we're going to type in that n equals brackets, not nm. N equals brackets 2, 3, 4, 5, 6, 7, 8. See, a bad sign where I know I've done something wrong at this point is that x sub 1 keeps changing every time I add another variable. So I need to go back and check out what I've done wrong. So I have 70n here to the 1/5. That's correct. Times 70n to the 1/6. That's correct. And then all that squared is equivalent to 70n. Okay, so I didn't put parentheses around the 70n, which caused that 30x to be only multiplied by n. So now I just have to do that. Let's go ahead and see if it changes at all. Now that x is not changing, it's being constant. So that's one way you can check these answers. I didn't put parentheses around here. Always make sure your parentheses are correct. Your x is going to be 0.0177. And that's what the question is asking, for what value of x is that given expression equivalent. Okay, so those are the types of equivalent expressions you can do in Desmos. There's many that you have to do by hand, and these equivalent expressions are super tough. Save these problems for last. I cannot stress that more. You're going to have to, a lot of the time, play around with the problem until you get it right. Just skip these problems and go back to them if they are not the last question. Like I said, there's no specific steps for these problems. They're very specific to the problem. And if you can't figure out an obvious next step and you're working on this is your last problem, just try to combine denominators, because usually there's going to be more than one fraction and you want to combine those denominators and make it one big fraction. It shows that in a lot of the problems. And another good thing, I always do this first, is look at the answers to see if they will tell you where to go. If I see 3 fractions in my question and I see one big fraction in my answers, I'm going to know, okay, so it wants me to combine the denominators, set the denominators alike and combine them together. And if all else fails, play with the equation. If you are confused, look for greatest common factors, multiply by -1. There's plenty of things you can do if you are confused that just changes things up. So, which expression is equivalent to y plus 12 over x minus 8 plus y times x minus 8 over x squared y minus 8xy? So, I look at the answer choices. I see they're all one big fraction. So I want to combine. I definitely want to combine these fractions. So I'm going to look for the least common factor between these denominators so I can keep the denominator small. I can see that x minus 8 can be pulled out of the right side. And I'll show you guys what I mean by that right now. I have y plus 12 over x minus 8 plus y times x minus 8 over x squared y minus 8xy. So, one thing I notice here is there is an x in both sides and there is an 8 So I can pull out an x minus 8 from this equation here. So if I write this again, it's y equals x minus 8 over, let's pull out an x minus 8, x minus 8, times, we pulled out an x from here, xy minus xy. I believe that's... One second. X minus 8. Oh, sorry. You can't pull out an x minus... Or, yeah, you can pull out an x minus 8, but the thing you should be pulling out here, x minus 8 is a factor. You can see there's an xy on both sides, and if you pull out an xy, it'll give you x minus 8. So you pull out an xy because this will simplify to x. X squared y divided by xy is just x. Negative 8xy divided by xy is negative 8. So there's your x minus 8. You pull x minus 8 out and you're left with xy. So now we know that all we need to do to combine both of these fractions is we need to multiply this side by xy over xy. And then that'll give us common denominators. So xy over xy. And I'm not even going to simplify this. It's not even worth simplifying yet because we don't know if one of the questions is going to have that look in it. So xy times x minus 8. So now both of these denominators are similar, so now you can make it into one big fraction. I'm going to erase this top part. So xy times y plus 12. Now remember, this is over one big fraction. Now this is over xy times x minus 8. And then plus y times x minus 8. Now I'm going to look at my answer choices to see if any of them match up with what I have now. A, that denominator is obviously different from what I have. So is B. But C, it looks pretty close. What it is that's different is this xy is distributed back out. So let's distribute the xy back out. X squared y minus 8xy. And that is the same denominator as C. So we see it has a different numerator though. So now I know I'm going to have to distribute out everything in the numerator. Xy times y is xy squared. Xy times 12 is 12xy. Y times x over here is going to be xy, so plus xy. And then y times negative 8 is going to be 8y, negative 8y. So now we have this simplified. We can combine our like terms. We can combine our xy. Xy squared plus 13xy minus 8xy all over x squared y minus 8xy. Let's look at our answer, see if that's similar. The numerator and denominator match up. So the expression that is equivalent to y plus 12 over 8 minus x plus y times x minus 8 over x squared y minus 8xy is going to be C. As you can guys see, those questions they're ridiculous. These SAT questions are time wasters, so that's why I said skip this question until the end. It is not worth doing these types of questions unless you have time. They're the last questions you should be doing when you run out of time on the Math Module 2 section. Oops. which expression is equivalent to 42a over k plus 42ak, where k is greater than 0. So let's write this out. 42a over k plus 42ak. So I'm going to look at my question, or my answer choices again, and I see they all are over k. They're one big fraction again. So I'm going to try to make this one big fraction. Well, what I want to do to make this one big fraction is I want to multiply this side, because this is over 1, by k over k, so I can get common denominators. So 42a over k plus 42ak times k is 42ak squared over k. Now we add those together. That would give us 42a plus 40. That's a really bad 4. 42ak squared all over k. Now I'm going to look back at my answer choices now that I made it one big fraction. A, it does not look the same at all. B, it does not look the same at all. You cannot combine a and ak squared. C could be it, they take out a GCF, and D could be it, they take out a GCF. So let's go ahead and take out our greatest common factor here between these two, because that's obviously what C and D did. So it's going to be over k. In your factors, the greatest common factor between these two is 42a. So if we take a 42a out, that leaves us with 1 plus, you're left with k squared over here. So 42a times 1 plus k squared. And you can switch that k squared and that 1 around, make it k squared plus 1, and that is going to be equivalent to your answer choice D. That's like the 4th time I've done it. This slide is messing with me today. Here we go. Sorry about that. Finding integers with integer factors. This is another topic. This is honestly, for me, another equivalent expressions thing. This is just as hard, if not harder, than solving those hard equivalent expressions by hand. Because this is very conceptual, and if you don't understand like every little part of algebra sometimes, you're just not going to get these. So I'd look and stare at these for a minute on the actual SAT, but not longer than that if you're not going to get it by then. So, multiply the factor or factors out to find equivalent pieces. If you have multiple factors, like, let's say x squared plus 6x, that's a 6, sorry, 6x plus 8. You can factor that out into x plus 4 and x plus 2. On the SAT, they might set these factors equivalent to constants. So it might be like x plus a, x plus b. So if you multiply this out, x times x is x squared, x times b is bx, plus a times x is ax, and a times b is ab. Well, we know AB is equivalent to 8 because that's the only thing without an X on it. So if we have constants like that, we're going to automatically know that AB is equivalent to 8. we know that b plus a is equal to 6 because those are the two things with 6's on them. Or those are the two things with x's on them, so they have to equal 6 together like our original equation. So a and b would have to be 4 and 2. So if it gives you integers like this, you can get so much information out of just like multiplying these factors out. And what multiplying these factors out does is it gets both of those expressions in similar form. If you look at these two expressions here after I multiplied those factors out, you have an x squared in both of them. You have a bx. There's 2 in the second one and 1 in the first one, but you still have an x, and then you have that constant at the ends. So just knowing, putting the expressions in similar forms is going to help you a lot with these problems. Alright, let's try a few of these. The expression 4x squared plus bx minus 45, where b is a constant, can be written as hx plus k times x plus j, where h, k, and j are integer constants. Which of the following must be an integer? So we know 4x squared plus bx minus 45 can be rewritten as hx plus k times x plus j. So the first thing I'm going to do here is I'm going to multiply this out to see if I can figure out if any of them are going to be equal to an integer, because the question is asking which of the following is going to be equal to an integer. So I'm going to go ahead and factor this out. Hx times x is hx squared. Hx times j is hjx. K times x is kx. And then k times j is kj. So we see that these two, it's given that these two expressions are equivalent. So hx squared is the only thing with x squared by it. So therefore your h coefficient must be equal to your 4x here. So h is equal to 4. We're given one of the integer constants. We know hj plus k must be equal to b, but since we're not given b, that's not any good information. And lastly, we see that our constant on the end here is negative 45 and kj. So we know that kj must be equal to negative 45. K times j equals negative 45. So we know k and j are both factors of 45. That's going to be important to know for this problem. Which of the following must be an integer? We have no clue what b is still, so b over h, we don't know if that's an integer, so we'll just ignore a for now. B over k, we still have no clue what b is, so we're going to ignore that for now. 45 over h, we know what h is now. So we can plug in h. 45 over 4, that's not going to give us an integer. It says which of the following must be an integer, not must not be an integer. So 45 over h, C is not your correct answer. 45 over k, if we look back to this kj equals negative 45, j equals negative 45 over k. Because if you divide k over, on both sides, you can get that j equals negative 45 over k. J and k are factors of 45. Therefore, if you divide 45 by j or k, it's going to give you an integer, no matter what sign. If you divide 45 by k, it's going to give you j, and if you divide 45 by j, it's going to give you k. And it gives in the equation that they're all integer constants. So therefore, 45 over k, d, must be an integer. Is there any questions on how I got to that? K minus x is a factor of the expression x squared negative x squared plus 1 over 29 times nk squared. Negative x squared plus 1 over 29 times nk squared, where nk are constants with k being greater than 0. What is the value of n? So we're given that k minus x is a factor of this. Well, we know there can't just be one factor, because if k minus x is the only factor, then that expression would be k minus x. So k minus x must be multiplied to something else for it to be equal to that expression. In the thing we have to look at to figure out now is that both of the variables dash constants in this expression here are squared. So this is going to be, if you rewrite this, let's put x behind. Let's put minus x squared back here instead of negative x squared out front. So you have 1 over 29 nk squared minus x squared. That's going to be your difference of squares factors. So that's going to be k minus x times, you have x squared in the back, so it's going to be plus x. So negative x plus x is going to give you that negative x squared in the back. So you can see that that's already going to be your second factor. And then how do we get to 1 over 29 times n? We would have to, since this is a difference of squares, it's equal to k minus x times k plus x. Because here, I'll show you why it's a difference of squares. If you multiply k times k, you get k squared. If you multiply k times x, you get kx. If you multiply negative x times k, you get negative kx. Once you get here, these two cancel. This is a positive kx, this is a negative kx, so these canceled. So it's just going to be k squared minus x squared. That's going to give you your final answer. So the second factor is going to be k plus x, because that's the only way you can get to 1 over 29n times k squared. This problem totally hinges on you realizing that that first expression is a difference of squares, and that the factors are going to be difference of square factors. So our simplified equation here is k squared minus x squared. So 1 over 29 n k squared minus x squared equals k squared minus x squared, because that's how your factors work. They're going to give you an expression that's equivalent to this. So the only thing we see that's wrong here is this k has a weird coefficient here, 1 over 29n. Well, it's asking what the value of n is. To get k squared's coefficient to be 1, we gotta realize that n is going to have to be 29, because 29 times 1 over 29 is going to equal 1. So n being equal to 29 would give us our k squared minus x squared. So our answer is going to be D, 29. These problems are crazy. Like, I don't like them. Save those problems for last. And you're usually not going to get both of these types of problems on the same SAT. It's usually going to be one or the other. Maybe you'll get 2 in total for an SAT, but I haven't seen that yet, I don't think. So, solving for one variable here, you'll see what I mean with this title when we get into the questions. You want to save these for last as well. This is similar steps as the hand-done equivalent expressions. You do similar steps as these types of questions. You're just isolating a variable. Like, it might give you like xy plus 17x equals 32, and it's going to ask you to get everything in terms of y. So you're just isolating a variable. But a lot of these questions are really, really tough. And a big thing you want to do when you're looking at these problems is you want to look for those greatest common factors. Those greatest common factors are going to make everything so much easier. Plus, the answers always factor out a GCF, like most of the time. I haven't seen very many problems when they don't factor out a GCF. And if you're confused, look at the answer choices. Answer choices give you the answer. They're going to show you what you maybe haven't done yet. So let's go on and try to do some of these questions. The equation relates the positive variables p, q, r, and s. Which of the following is equivalent to q? So let's write out this expression. 20 over p equals 20 over q minus 20 over r minus 20 over s. So the question is asking what's equivalent to q. So I want to get q by itself. The first thing I'm going to do is I'm going to add over that 20 over r and that 20 over s. This is an s, not a 5. To get that fraction with q by itself. So 20 over q equals 20 over p plus 20 over r plus 20 over s. So now I've gotten the fraction q by itself. But q's in the bottom. That's our issue here. I can't figure out a way from here to get q by itself. So the first thing I'm going to try to want to do is I know that I can get q on the top if I make the other side equal to one big fraction and I cross multiply. So the next thing you're going to want to do is you're going to want to give all of these equal denominators so you can make it into one big fraction. So the least common multiple between p, r, and s is p, r, s. So you want to multiply your 20 over p by rs over rs. You want to multiply your 20 over r by ps. And you want to multiply your 20 over s by PR. PR over PR. So now you'll get the equation 20 over q equals. now that you've multiplied all of your things to give them the same bottom portions, and I'm going to rewrite this. I multiplied this one by r over s. I multiplied this one by p over s. I multiplied this one by p over r. So now the denominators are all equal, so now you can add the top two together. So 20 over q is equal to 20 rs plus 20 ps plus 20 pr, all over prs. So now we have our expression equivalent to this. Sorry about that. The next thing I want to do is cross multiply q, because my whole thing with here was trying to get q into the numerator so I can divide everything else over. So 20 times PRS is 20 PRS, and then all this times q is q times 20 RS plus 20 PS plus 20 PR. So now you have q times all this. All you have to do to get q by itself is divide by this whole thing. And that'll get you the equation q equals, I'm going to write the bottom first because the bottom is much bigger, 20 RS plus 20 PS plus 20 PR all over 20 PRS. Now I got q by itself. Perfect. So I should have a multiple choice answer here. A, P plus R plus S. Well, that looks nothing like my answer choice, so I'm going to ignore that for now. B, 20 times P plus R plus S. Again, that looks nothing like my answer choice, so I'm going to ignore it for now. C, PRS over PR plus PS plus RS. Well, that looks very similar to my answer choices. The only thing different is there's no 20s in it. So I'm going to look at my answer. I see here that I can cancel out all these 20s because, let me do this in blue instead of purple. There's a 20 in every single part of the numerator and the denominator, so I can go ahead and take out a 20. So our answer would go to q equals PRS over RS plus PS plus PR. Well, that looks almost like my C still, but PR and RS are switched. Since they're all connected by addition, you can kind of swap those around any way you want. C just has the answer in a different order than I have the answer in. But your answer is going to be C. With these things, the hardest part is going to be finding the variable by itself. Once you can get the variable by itself, you're able to take out a GCF, multiply by some random factor, and turn it into one of the answer choices. The given equation relates the distinct positive real numbers w, x, and y, which equation correctly expresses w in terms of x and y. So this one wants me to find w by itself. So let's go ahead and try to figure that out. 14x over 7y equals 2 times w plus 19. Well, the first thing I want to do if I'm getting w by itself is this 2 right here needs to go, because when I square both sides, that 2 being there is going to not work out well for squaring, and it's going to be really annoying. So if I simplify this, it's 14x over 14y equals w plus 19. Well, if you notice in this part of the equation, there's a 14 in both the numerator and the denominator, so this can cancel out. Let's just try to make this as simple as possible. So you get root w plus 19 equals x over y. Now you can square both sides. W plus 19, because I squared everything, w plus 19 equals x over y squared. I'm going to go ahead and erase this stuff so I have more space. Now we want to subtract 19 over. W equals xy squared minus 19. Well, I got w by itself, so let's see if we can find any answer choices that look the same. W equals root x over y minus 19. No, my xy is squared. Root 28x. No, there's a root right there. W equals x over y squared minus 19. That is exactly my answer. I didn't have to do any sort of multiplying out or making it into one fraction. So your final answer is going to be C.